Determination of chloride ions in the water using titrometric 9-to-5 method.
Hello guys, today we are going to talk about the determination of chloride ion in the water using a titration method. So in this titration method, basically we are going to titrate the water sample using the known concentration of silver nitrate solution, which is 0.014 molar, and the indicator which we are going to use here is potassium chromate. So potassium chromate can serve as a endpoint indicator for the titration. So titration here, we can also call this as Argentometric Titration or Mohr's method. Okay, so what happens here when we are going to titrate using silver nitrate? It is going to form a precipitation reaction, and at the end we are going to get a reddish brown color, or you can say a brick red color. So for finding out the chloride in the water, we need, this is a DG titrate, you can see here, okay, and then we need, this is our indicator, which is potassium chromate, okay, and for finding out we need some water sample. So before finding out the chloride in the water, first of all we have checked the pH of this is around 6.5, okay, 6.5 to 7, okay, this is our tap water sample, and then we have to add some drops of indicator. When you add indicator in this, so it will turn yellow, okay. We have to make sure that there is no air bubbles here. Okay, we'll be putting it down, okay. Okay, so we have purged the air bubbles here. Also this is set at 0, so we will try to drop slowly and slowly our titrant. This titrant is silver nitrate, 0.014 molar, and already this is standardized. So you can see there is a color change. Our final endpoint, which is brick red color, and it consumed around 8 ml of the titrant. So using a simple formula, we will find out the amount of chloride in the unknown water sample. So guys, this is our second sample, which is a seawater sample, and this is diluted 5 times, okay. So again I will follow the same process step. So I'll add indicator, and then I will start to titrate, okay. Since it has a high amount of chloride as compared to the tap water, so it will be consuming a lot of titrant, okay. So that is why I have diluted it, okay. So before carrying out the chloride analysis, also sometimes we need to have an idea how much amount of chloride is in the water sample, okay. So if we don't dilute the sample, we will be consuming unnecessary amount of the titrant, okay. So this is around 51.85 consumption. Still the color has not changed. We could not reach the endpoint. So what we will do, we will start again from 0. So we will reset, okay, and then we will try to fill up the solution again, the titrant. So we reset, and then we will try to add again. So you can see the endpoint, it consumes a lot of silver nitrate solution, okay, 0.014. So this is our endpoint, okay. So it consumes around 180 ml of the 0.014 molar silver nitrate solution as a titrant. So now we will be calculating, using simple formula, what is the amount of chloride ion in both the samples. Then we can have a comparative evaluation of the normal tap water sample and a seawater sample, okay, which has a lot of chloride ions, okay, or other ions also. So guys, you can see here, this is the simple formula for finding out the amount of chloride in the water. So here this is N, okay, and this is the factor here, and then this is multiplied by 1000, and it is upon the volume of the sample, okay. So in the first case, we saw that it consumed around 7.9 ml of the titrant. So A is the volume of the titrant and N is the normality of the titrant. Okay, so it is 0.014 and this is a factor. So this is approximately equal to, okay, if we find out using a simple calculation, so it is 78.41 ppm. Okay, on the contrast, if we see in the seawater, which is having a high amount of chloride, so and we diluted that 5 times. Okay, so this number is very high. You can see this is 1786.68, so which is very high as compared to the tap water.